Welcome you again to this lecture series of multivariate calculus. So in this lecture I will talk about the chain rule. Okay. So let's understand what is chain rule. Suppose we have this function z equal to fxy, no problem, right? So z equal to fxy, and where x is another function of two variable u and v, when y is another function of the same two variable uh, u and v. Then we can find the then z basically will be a composite function of u and v, right? In the place of x, if you write phi of uv, and in the place of y, if you write that is psi of uv, then basically this will be a composite function of u and v. Then we can find out the partial derivative of z with respect to u and with respect to v in this way. So see that del z del u equals to del z del x plus into del x del u plus del z del y into this one. Okay, so let's understand how it's basically going on. So we want to find out the partial derivative of z with respect to u, right? So this is the partial derivative z with respect to u. But before that, so it will be basically composite of two functions u and v, right? And originally this function z basically x and y. So first I will partial derivative this function z with respect to x, and inside x I have u. So I'll first partial derivative z with respect to x, then x with respect to u, because x is a original function of u. So to get this term del x del u, I have to first differentiate partial derivative, find a partial derivative of this z with respect to x. Similarly, I'll find out the partial derivative of z with respect to y, then partial derivative y with respect to u. Okay, so this is basically the chain rule because it is one by one. So first z is a function of x, so partial derivative z with respect to x, then partial derivative of x with respect to u, that we are finding out, then z also another function of y, and they are also involved u, so multiplication of del u, so on. Same for the partial derivative of z with respect to v. So here we'll do del z del x and del x del v plus del z del y and del y del v. So we'll use this pattern, like this is also called the chain rule. So that's all about the chain rule. Now let's apply this method in one example. Suppose we have a function z that's equal to f of x plus ct and phi of x minus ct, and we have to show this del 2z del t square equal to c square del 2z del x square. Now if I think that x plus ct is a new function, let's say u equal to x plus ct and v equal to, let's say, x minus ct, then z will be a function of f of u and v of phi of v, right? So z basically a function of u and v, and u is again a function of x and t, where c is a constant. Okay, c is a constant in this equation. So f is a function of u and v, and u and v are also a function of x plus ct, and y v is a function of x minus ct. Now I have to find out this relation holds, the del 2z del t square equal to c square del 2z del x square. So here I'll first finding out what is del z del t. So by using the chain rule, so it will be del f del u into del u till t. Similarly, del phi del v into del v dt, right? So I know what is the del u del t, right? So del u del t basically it will be c x will be 0. This term will be with respect to partial derivative t, it will be gone out. Only c will be there, and similarly del v del t, this term negative c will be there because this term will be 0 and t that will be 1. So this will be del f del u c plus del phi del v into negative of c. So I can take out c common. So I can write at del phi del u negative of del phi by del phi, right? So on. So I write down the. So I differentiate this previous function, because ultimately we have to reach out del 2z del t square. So I again differentiate this function with respect to t. Basically we are differentiating this function with respect to t again. So then I'll get this function that I already find out. So next del 2z del t square. So say c is constant, so I can take out this outside of this differentiation. Then I'll get del phi del u negative of del phi del f del u negative of del phi del v, right? Again we apply the chain rule here to finding the differentiation. So I'll apply del u del u del f del u, so then del u del t. So here basically we are changing that differentiation. So first we are differentiating with this function, not directly t. First we'll by u, then after that we are adjusting this del t here by this way. Similarly, we cannot directly finding out the partial derivative of this function with respect to t. First, we have to differentiate this function with respect to b. After that, partial derivative of this v with respect to t. Now, you know that x equal to x plus ct and y equal to sorry v. So b equal to basically x minus ct. So again you can put these two value del u del t that equal to c and del v by del t equal to negative c. So again c will be here and negative c will be here. So negative negative positive. So ultimately I'll get so this will be del 2f for del u square, and this term will be sorry okay. So after that this term will be c and here it will be negative of c. So del 2f del u square and negative of c, and ultimately I'll get sorry there is some mistake, so it will be basically del v square because we are differentiating this one with respect to p, and here we'll also get del v square. So ultimately I'll get c square del 2f del u square plus del 2 sorry again, so it will be del 2 phi. So it will be del 2 phi del v square and del 2 phi del of u square. Okay, so I find out del 2z del t square in this in the form of del 2f and del 2 square and del 2 phi del v square. Now I have to show that this del 2z del t square, that is basically equal to some c square into del 2z del x square. I have to show this one, right? So one side I have find out this one equal to this term. Now again I find out what is del 2z del x square. So for that, so I write this is as equation number 1. So I know that z equal to this one. Now again here we'll find out what is del z del x. So that is by using the chain rule I can differentiate in this way, and here you know that u equal to x minus x plus ct and v equal to x minus ct, right? So it del u del x, that will be equals to 1. This will be 1. This will be gone out, and del b del x, that will be 1. Right? So I can write that del z del x equal to this one. Now again I am differentiating this one with respect to x partially. Then by using the chain rule again, I can find out the differentiation in this way. So I have to differentiate this one with respect to x and with respect to e and we are adjusting here, and similarly here we are differentiating with respect to v, and we are adjusting del x here, and I know this del u del x and del v del x that equal to 1, and this is equal to del 2f del u square and del 2 this one, and from the equation number 1 the previous slide I can get del 2 del square equal to c square, and this value equal to del 2 del x square, and sorry, so it will be del x square. Okay, so that's all. By using the chain rule, we proved this uh, equation or the solve this problem. Thank you for listening. See you in the next lecture.